Hi class, welcome to lesson 44, the last and final lesson in unit number 6. That means a unit test is coming soon. Start studying now so that you are prepared for your upcoming exam. In this lesson, we will describe how to calculate mole ratios for chemical reactions. You may take guided notes or take notes on your own, but make sure you take notes. Let's get started. When we look at this reaction, we can see that it includes numbers that work similar to coefficients in chemical reactions. So we know if we only had one egg, we would only need a half a cup of water. Or if we had 2 boxes of mix, we could make 2 cakes. If we had 6 eggs, how many cakes do you think we could make? We could make 3 cakes. The coefficients in the chemical reaction tell us the number of moles or the amount of a substance we need for a reaction. So when we look at this synthesis reaction, you can see that 4 aluminum and 3 oxygen produce 2 aluminum oxide, but we can also say 4 moles of aluminum and 3 moles of oxygen produce 2 moles of aluminum oxide. When calculating mole ratios, there are 2 steps. Set up a ratio or a proportion by underlining the species examined and the actual mole given from the problem. From here, we'll have 2 fractions that we can solve for the unknown. Check and make sure that the same substance is described in one fraction. Let me show you how this is done. Now you should be able to calculate the mole ratios for a chemical reaction. In this unit, we've discussed a lot of different ways to solve. In this unit, we've discussed a lot of different math problems that have different techniques to solve. In this unit, we've discussed many different techniques to solve about information from chemical reactions. So let's take a minute to review what some of the key features are so we know which technique to use. So let's work through this example. In this question, we are asked, how many moles of nitrogen gas? So I'm going to circle nitrogen gas in the problem, and I'm going to look for the nitrogen gas in the question, which I see is here. I'm just going to underline it. So see how this matches? How many moles of nitrogen gas would be needed to produce 10 moles of ammonia? So here we have 10 moles of ammonia in this reaction. So ammonia is right here. We're going to underline it. Now, when I go back and reread, it says how many moles of nitrogen gas? We don't know the amount of nitrogen gas, so we'll call it X. And we know that we want to produce 10 moles of ammonia gas. So I'll call this 10. So this will go and set us up to make 2 equivalent fractions based on the coefficient. So the coefficient on nitrogen is not written, but it's understood to be 1. So my fraction is 1 over X from the nitrogen and 2 over 10 from the ammonia. I set these equal. To clear the denominator, what I'm going to do is I'm going to multiply these 2 values, and then I'm going to multiply these 2 values. Solving, by dividing by 2 on each side, I can see that X equals 5 moles of nitrogen gas. Notice that my fraction for the nitrogen has the nitrogen from the question and the X because I'm looking for nitrogen. And everything in this fraction describes the ammonia. Let's try and solve this problem together. This question, it asks, how many moles of oxygen? So I'm going to circle moles of oxygen. I'm going to find oxygen. Here's oxygen, so I can see, put this value here, are consumed when 0.6 moles of hydrogen. So I'm going to find the hydrogen. Here it is, and I'm going to underline it here. So again, the question says, how many moles of oxygen? So oxygen is our X, and we can see that we have 0.6 moles of hydrogen. So we know this. So from here, I'm going to write the fractions as given from here. So this, take the coefficient, it's 2 over 0.6. And my other fraction, remember the coefficient on the oxygen is 1. So that's 1 over x. We're going to set these fractions equal to one another. And to clear the denominator, I'm going to multiply these two first. Then I'm going to multiply these two. And from here, what's going to happen is I'm going to solve. So when I solve, I'm going to get that x equals 0.3 moles. And then I was looking for oxygen. So this is my answer. Let's do one final question together. In this question, it asks if 0.7 moles of propane, so here I am given this value, connects with this formula, reacts completely, how many moles of water are formed in the reaction? So here I have water, and I'm looking for water. And I go back to see what I know. So it says if 0.7, so that goes with the propane. How many moles, so that's X, of water. So when using mole ratios, we can describe any two substances in a reaction. So it could be a reactant and a product, or two reactants, or even in this case, we could describe the relationship between these two products. But this question is just looking at these two substances. And now we're going to take what we know and write it down and set equivalent fractions. So remember that we're looking at the coefficient. This coefficient is understood to be 1. So 1 over 0.7. And then for the water, which is here, we have a coefficient of 4 over x. So we're going to set our fractions equal to one another, and to solve, I'm going to multiply these two items together, and then I'm going to set that equal to these two items. So here I have 2.8 moles of water. In this unit, we've described many different mathematical relationships between formulas and chemical equations. So a lot of students struggle to remember which technique to solve each kind of problem. So here we're going to do a quick review of the 3 different types of problems you could have and how you could solve each of them. So some questions will give you 2 different amounts of grams, and that will have a law of conservation of mass approach. Some questions will give you either grams or moles and ask you to find the other. That will use reference table T's mole calculation. And sometimes you'll be given moles of 2 different substances, like we discussed in this lesson, and here we will have to apply the mole ratio method. So let's look at each and every method. So here, if we are given two different amounts of grams, we are going to use the law of conservation of mass, which says the total grams of reactants must equal the total grams of products. So in this sample question, we were asked to determine how many grams of oxygen are needed to react with 70 grams of lithium to produce 150 grams of lithium oxide. So what we know here is, it asks how many grams of oxygen, so we'll just write X, are needed to react with 70 grams of lithium. So I have 70 grams to produce 150 grams of lithium oxide. So recall that matter cannot be created or destroyed. This arrow is the same as an equal sign, and this plus we'll have here. So when we solve for X, we are just going to figure out how many grams must be added to 70 to make 150. So in this case, X equals 80 grams. So the next kind of question we can be given is seen here, where we're given 1 gram and or 1 mole in the equation. So here we're going to have to use the mole calculation equation from reference table T. Let's look at an example. This example, we're asked to find how many grams are in 5 moles of lithium oxide. On the back of your reference table T, you can see the equation for mole calculations. The number of moles is equal to the given mass divided by the gram formula mass. So let's see what we can substitute here. So in this question, we know that we have 5 moles of lithium oxide. So that is the number of moles. So 5 is equal to a given mass over a gram formula mass. Well, we were not given a mass, but we can figure out the grams of the formula by using our periodic table. In lithium oxide, we have lithium, which has a mass of 6.9, and oxygen, which has a mass of 16. So lithium oxide, we have 2 lithiums and 1 oxygen. And when we use our non-graphing calculator, we will find that our new mass is 29.8 grams. So we're going to put the gram formula mass on the bottom of our fraction. And then to solve this fraction, it's easiest if we put this number over 1. And I'm going to multiply here. And you'll see that our calculator gives us the value of 149 grams. The last kind of problem you may have to solve occurs when you're given the moles of 2 different substances. Then you're going to have to apply the mole ratios. So when we look in this sample question, it asks how many moles of oxygen are needed to completely react with 10 moles of lithium. So here we're looking for moles of oxygen, so I'm going to underline oxygen. And I'm given that they're going to react with 10 moles of lithium. So I'm going to underline lithium. Now, I'm looking for oxygen, so I'll call it X. And I'm given that there are 10 moles of lithium. So this will allow me to set up 2 fractions. My fractions will be 4 over 10 equals, this coefficient of 1 is understood, 1 over X. To solve, I'm going to multiply to remove the denominator. And now, in order to isolate x, I'm going to divide by 4 on each side, and I will get x is 2.5, and that is how many moles of oxygen we have. This concludes lesson number 44. Make sure you've taken good notes. Write down any questions you have, bring them to class, ask them, and we will discuss them together. Complete your homework on Google Classroom and put your Regents Chemistry reference table and calculator back in your backpack so you are prepared for class. I'll see you soon.